All right, today we're diving into one of the most powerful and, frankly, terrifying inventions in all of human history, the hydrogen bomb. We're going to look at the science, the history, and just the sheer world-changing force behind this thing. So let's start with this question. How do you build a weapon that mimics the sun? I mean, it sounds like something straight out of science fiction, right? The idea of creating a tiny star here on Earth and packing all that power into a weapon. Well, that's exactly what we're going to figure out.
And the secret, it all comes down to something called a thermonuclear reaction. To understand how you build a sun on Earth, you first have to get a handle on what makes a hydrogen bomb actually work.
So here's the core of it. A hydrogen bomb, which you'll also hear called a thermonuclear bomb, is a weapon that runs on nuclear fusion. And get this, that is the exact same process that our sun uses to create light and heat. We are literally talking about bottling the power of a star.
Okay, to really wrap our heads around this, we need to look at two different but totally related nuclear processes. You've got fission on one side, and then you've got the star power of fusion on the other.
So first up is nuclear fission. The easiest way to think about this is just breaking something really big apart. You take a heavy, unstable atom, think uranium, and you split its nucleus. This split releases a massive amount of energy, and it's the tech that was behind the very first atomic bombs.
And now, fusion. This is the exact opposite. Instead of splitting atoms, you're smashing two really light ones together so hard that they actually merge into one. For this, scientists use isotopes of hydrogen. And the energy that comes out of this process, it is just monumentally, exponentially greater than fission. It's a whole other league.
This comparison just lays it all out, doesn't it? Over on the left, you've got fission. A neutron hits a big uranium atom, and poof, it splits. But on the right, you see fusion. Two light hydrogen isotopes are slammed together to make helium. Just look at the difference in the process, the fuel. This is the huge leap in technology and in raw power we're talking about.
So here's the million-dollar question. If fusion needs these unbelievable temperatures and pressures, like what you'd find in the core of the sun, how in the world do you create those conditions here on Earth? Well, the answer is an incredibly clever and pretty terrifying two-stage design.
Let's just walk through the four key steps. First, a smaller, conventional atomic bomb, that's your fission trigger, goes off. Second, that initial blast creates the absolutely insane heat and pressure you need. Third, that crazy environment ignites the fusion fuel. And the result, step 4, is just a catastrophic release of energy.
And this right here is the famous Teller-Ulam design. The key takeaway is that you're essentially using one bomb to set off another, much, much bigger one. That primary stage is a fission bomb. Its explosion is all focused inward, compressing and heating up the secondary stage, which is where all that fusion fuel is waiting.
This shows that sequence just perfectly. The atomic explosion on the left creates the brutal conditions needed for the fusion fuel to light up. That first blast acts like a cosmic vice, squeezing and heating that fuel until bang, it undergoes fusion and unleashes an amount of energy that's almost impossible to imagine.
Now, a technological leap like this doesn't just happen in a lab somewhere for fun. It was born from one of the most tense and dangerous periods in modern history, the Cold War.
This timeline really shows you how fast everything escalated. In 1949, the world was stunned when the Soviet Union tested its own A-bomb. All of a sudden, America's nuclear monopoly was gone, and the arms race just kicked into hyperdrive. That immense pressure led directly to the United States testing Ivy Mike, the very first H-bomb, just 3 years later.
And the minds behind this breakthrough? Well, two of the key figures were the physicist Edward Teller, who's often called the father of the hydrogen bomb, and the mathematician Stanislaw Ulam. It was really their combined genius that cracked the code on how to build a working, two-stage thermonuclear weapon.
So we've seen how it works and where it came from. But to really get a sense of the hydrogen bomb, we have to try and grapple with its immense, almost unthinkable power.
You see, the first atomic bombs, their power was measured in kilotons. That's thousands of tons of TNT. But for thermonuclear weapons, that scale just wasn't going to cut it. They needed a whole new unit of measurement, the megaton. 1 megaton is equal to 1 million tons of TNT.
So what does that really mean? It means the destructive power of a single hydrogen bomb can be over 1,000 times greater than the bomb dropped on Hiroshima. Just let that sink in for a second. 1,000 times. It's a leap in destructive force that's almost impossible for our brains to fully comprehend.
And the effects, they're truly apocalyptic. We're talking about shockwaves that can flatten entire cities, heat so intense it creates its own firestorms, a flash of light that can cause blindness from miles and miles away. And then, long after all that, you have the quiet poison of radioactive fallout, contaminating the land for decades.
By creating a weapon that can mimic the sun, humanity gave itself a power that could literally threaten civilization as we know it. The hydrogen bomb changed geopolitics, it changed warfare, and it changed our understanding of our own capacity for destruction. It leaves us all with a pretty profound question to think about. What is the true legacy of wielding the power of a star?